In this lesson video, we are going to discuss about manifold versus non-manifold geometry. So what is a manifold object? Well, there are several terms related to manifold actually. Standard manifold and solid manifold. You can check about the differences online. But for our lesson, just to make things simple, we will assume that these manifold types are the same. So in short, a manifold 3D object is a 3D object that can exist in the real world, or they can be unfolded into 2D planes without any normals facing problem. By now, you should already know that 3D models in Blender or in any 3D digital content creation software are actually hollow. They are not solid. They are like papercraft glued together. But when doing modeling, we need to imagine that they are solid objects. Basically, the surfaces of our 3D model need to be watertight, no holes, and there should be no face intersection. Also, there should be no edges or vertices floating around without faces attached to them. If you have a non-manifold 3D object and then try to export and print it with a 3D printer, it will produce an error message as the structure is just impossible to exist in the real world. Let's see several examples of what we are talking about. We have this cube. Now this cube is manifold. It can exist in the real world. Now if we go to the face mode, select this face and then press X and then choose faces. We have a hole now in our geometry. Our object now categorized as non-manifold. We have exposed a flat, zero thickness surfaces here, which is impossible to exist in the real world. Even papers in the real world have some thickness, while these open faces have a complete zero thickness. This kind of non-manifold will get you an error when you try to 3D print the object. The next non-manifold is face intersection. If I select this edge and then press E to extrude, we now have three faces intersecting on a single edge. This kind of geometry is very bad. This is not acceptable at all, whether for 3D printing or for any other usage. Basically, an edge must always have a maximum of two faces attached to it. So you should always avoid this kind of non-manifold at all costs. In my experience, this kind of non-manifold happens a lot when importing models from SketchUp. Because in SketchUp, when you create lines that loop, it will create a polygon or face automatically on that loop, resulting in edges with more than two faces intersection. So this is something you need to be aware of when importing 3D models from SketchUp. The next non-manifold is floating edges and vertices. For example, if we go to the vertex mode, then select this vertex, hold Ctrl and right-click here, then here, and so on, we can actually create a structure of edges and vertices without any faces at all. It is possible to do this in Blender, and this feature is also quite useful in the modeling process. But you should never export a 3D model like this. Again, don't get me wrong here. You may use floating edges and vertices, but only in the development phase, not for the final product. We are going to cover how to utilize floating edges and vertices for modeling in the next project lesson. The last non-manifold we are going to discuss is a single vertex that holds two or more non-linked geometrical structures. For example, let me create a new cube here. Go to the edit mode. Scale this on Z-axis, Ctrl R, scroll until we have three loop cuts, click, and then right-click. Now, if we select the middle edge loop, press X, and then choose Edge Collapse, we'll get something like this. One vertex holding two mesh structures. This kind of geometry is very bad, and you must avoid something like this in your 3D model. Not all 3D models that we create is for 3D printing purpose. Most often, we need them for still image rendering, animation, or exporting them to external game engines such as Unity or Unreal, for example. For these scenarios, there is no problem at all if you have these two types of non-manifold and they are flat faces and overlapping geometry. So for example, if I create a plane object like this, then create another object, let's say a UV sphere, which is intersecting the plane object. This flat plane object doesn't have any volume, so it is actually non-manifold. And this sphere object intersecting the plane object like this, which is actually non-manifold also. But these objects are completely acceptable in animation or in game development, so you don't need to fix anything at all. Sometimes we need to work as a team and need to import other people's 3D models. Unfortunately, the 3D models that we import are not always perfect, and finding non-manifold problems in a 3D object manually can be troublesome. Alhamdulillah, Blender has a method to select all non-manifold vertices, provided the objects we want to check are joined as one object. Here, I have an example 3D model which was imported from SketchUp. I also add some non-manifold problems in this model on purpose, just for the demo's sake. To check for non-manifold vertices, first, you need to be in the edit mode and in vertex selection mode. Press Alt-A to deselect all of the mesh elements, then go to the select menu, choose select all by trait, and then choose non-manifold. As you can see, all non-manifold vertices are selected automatically. From here, you can use different modeling methods that we have discussed earlier to fix the model manually.